Assalamu alaikum. My name is Samra and my roll number is 18. Topic of my presentation is Kevlar fabric chemistry and its applications in medical industries. First, we will discuss about the contents of the presentation: introduction, history, chemical reaction, production, structure and properties of Kevlar fabric, advantages of Kevlar fabric, and disadvantages of Kevlar fabric, and the last one is the applications of Kevlar fabric in medical industry. First of all, let's have a look on Kevlar fabric. What is Kevlar fabric? Kevlar is a renowned synthetic material known for its strength and durability. Understanding the chemistry behind Kevlar fabric can provide insight into its impressive properties and wide range of applications. It means that Kevlar fabric have impressive properties, and due to these properties, it has large number of applications, and therefore it is a renowned synthetic material, and it is specifically known for its strength and durability. Let's discuss about chemical composition of Kevlar fabric. Kevlar is a polyamide. Poly means chain, amide means a amide group, which contains NH2. So Kevlar is a polyamide, which means it is a polymer made up of repeating amide groups. Polymer means chain, a chain of amide groups repeating. These amide groups are formed from a reaction between a dicarboxylic acid and a diamine. When two compounds react with one another, they form polyamide. One is dicarboxylic acid and a diamine. In the case of Kevlar, the specific chemical used are terephthalate chloride and paraphenylene diamine, which are carefully combined in a process known as polymerization. These are the chemicals which we can use in Kevlar fabric, while the reaction of dicarboxylic acid and a diamine, they are compulsory, like terephthalate chloride and paraphenylene diamine. They are specifically useful for the combination of the entire process known as polymerization. Now let's talk about structural arrangement. The polymer chains in Kevlar are arranged in a highly ordered crystalline structure which contributes to its exceptional strength. This arrangement allows for efficient stress transfer throughout the material, making it resistant to tearing and puncturing. It means that polymer chains in Kevlar are arranged in a crystalline structure. That's why it has a high strength, and it can bear efficient stress. And why it can bear stress? Because it transfer that stress throughout the material, making it resistant. Therefore it is resistant to tearing. We can't tear it or we can't puncture it. Now let's talk about intermolecular interactions. The strength of Kevlar also stems from the intermolecular interactions between its polymer chains. These interactions include hydrogen bonding, van der Waals forces, and a pi-pi stacking, which all play a crucial role in enhancing the material's mechanical properties. Why Kevlar fabric is so strong? Because it has a number of intermolecular interactions present between its polymer chains. These are as usual, like hydrogen bonding, it may be van der Waals forces, it also includes pi-pi stacking. Therefore these all forces play a necessary, a compulsive role in enhancing the material's mechanical properties. Mechanical properties are its strength, its durability, uh, it's resistant to other mechanical properties. Okay, now let's talk about its introduction. What is Kevlar fabric and how it was introduced? Let's see. It is a DuPont's registered trademark for para-aramid synthetic fiber, which is made up by combining paraphenylene diamine PPD and terephthalate chloride. DuPont's registered trademark, the name the name of the person who made Kevlar fabric. It was made accidentally when he reacted a phenylene diamine with the terephthalate oil chloride. Kevlar has not been around for very long. Stephen Kollek, who worked for DuPont, made Kevlar in 1965. And and Kevlar, DuPont and Kollek worked in 1965 to manufacture a stronger tire. They were working on a tire, therefore, they made a Kevlar fabric. Instead of revolutionizing the tire industry, Kevlar revolutionized the entire world. It is a fiber that, when woven together, has the 5 times strength of steel. Kevlar was first commercially used in early 70s as a replacement of steel in racing car tires. Typically, it is spun into ropes or fabric sheets that can be used direct or as an ingredient in composite material components. It can be used in the placement of steel in the racing car tires. Typically, it is spun into ropes or fabric sheets that can be used direct or as an ingredient in composite material component. Composite materials are those materials which are formed by the combination of two or more compounds, two or more things. When they are combined, they have the properties of all the compounds present in that reaction. History of the Kevlar fabric. In 1964, Kevlar group began searching for a new lightweight strong fiber to use for light but strong tires. They were working on tires, so she decided to work on the lightweight tires because the Kevlar fabric made on that time was very strong, but it has a very high weight. So they worked on the weight of the tires. So the chemicals she had been working with at that time formed liquid crystals. When she was working in her lab, he formed some chemicals, and these chemicals formed liquid crystals while in solution. And in solution form, they have liquid crystals, something unique to those polymers at that time. The solution was cloudy, something like cloudy opalescent. Upon being stirred and of low viscosity, was not as much viscous and usually was thrown away. However, Kolak persuaded the technician Charles Mullen, who ran the spinneret, to test her solution and was amazed to find that the fiber did not break, unlike nylon. After Kolak discovered Kevlar, she was not very involved in developing the applications of Kevlar. So, let's talk about chemical reaction of the Kevlar fabric. Kevlar is synthesized in solution from the monomers paraphenylene diamine PPD and terephthalate oil chloride in a condensation reaction. The entire reaction is a condensation reaction because it condense the whole compounds and form a new material, uh, and something is removed as a byproduct from the reaction. So in condensation reaction, in which molecules of HCl are terminated as a byproduct. Condensation reaction is a type of reaction in which something is terminated as a byproduct. Hexamethyl phosphoramide was the solvent initially used for the synthesis, but for safety reasons, DuPont replaced it by a solution of N-methyl pyrrolidone and CaCl2, calcium chloride. Now let's see what's the reaction. It's paraphenylene diamine. It's a phenol group, and two amine groups are attached on its ortho meta para positions. Okay. When a paraphenylene diamine reacts with the terephthalate chloride, H from the PPT and Cl from the TCl removed as a byproduct in the form of HCl, and the temperature would be 10 to 20 degrees centigrade, and the reaction will form as a bond will be formed between NH and the carboxylic group of the TCl, and it forms a polymer of Kevlar fabric or PPTA. Another substance which is involved in the synthesis of Kevlar is highly concentrated sulfuric acid. We're not using dilute sulfuric acid, we're using concentrated sulfuric acid in the formation of Kevlar fabric. It is used to keep the crystalline Kevlar in the solution while it spins in the spinner. And why we are using sulfuric acid? It is because that we want to keep crystals of Kevlar in the solution when spin rate when we are when it spins in the spin rate. It is very difficult to use highly concentrated sulfuric acid because it's difficult to handle it, but it is a necessary process. That's why it is one of the most expensive step of production. We can't handle concentrated sulfuric acid, but it is a necessary process. That's why it is the expensive step of production, and we do in the synthesis of Kevlar fabric production. How can we produce Kevlar fabric? The product obtained in the laboratory is turned into fibers by a process called dry jet wet spinning. It is the name of the process through which we can produce Kevlar fabric. It is known as dry jet wet spinning, in which a hot and a very um, viscous solution of PPTA through a spinner to make long, thin, strong, and stiff fibers that are wound onto drums. The fibers are then cut to length and woven into a tough mat to make the super strong material we know as Kevlar. Okay, it is the name of the process which is called dry jetward spinning. And what happens in the process? We take a hot and a very viscous solution of PPTA in a spinneret and make long, thin, and something strong or stiff fibers, and they are wound onto the drums. There are drums, and we woven the whole fiber onto the drums. The fibers are then cut to length. When all it is done, we cut the fiber in length and bone into a tough mat and form a tough mat like structure to make the super strong material we know as Kevlar. It was the explanation of dry wet jet spinning method. Now let's see the diagram of dry jet wet spinning. Here is a piston attached to a reversible drive. Okay, there is a valve, a filter block, a spin rate pack, and a coagulation bath where coagulation happens. And there is a wash bath where the entire material is washed, drive and roll where the entire material is rolled down, a dancer, and a take up bobbin. So let's talk about the structure of Kevlar fabric. Uh, we have already talked about it is a terephthalate colloid and a paraphenylene diamine reaction. And when H from the NH2 of the PPD and Cl from the uh, dicarboxylic acid will be removed, and a bond formed between nitrogen and carbon of the carboxylic group, and then the reaction is called PPTA, and the oxygen of the carboxylic group and the hydrogen of the amine do hydrogen bonding with one another in the form of dotted lines. Okay, so it is the entire structure of Kevlar fabric. When Kevlar is spun, the resulting fiber has a tensile strength of about 3620 megapascal and a relative density of 1.44 gram meter per cc. Presence of a mild linkage and other interchain bonds like hydrogen bonds give this much high strength. The presence of salts and certain other impurities, especially calcium, would affect the properties of Kevlar. That's why care to care is taken to avoid impurities in its production. Uh, when impurities will be added to the to the reaction while production, while we are producing Kevlar fabric, the impurities will affect the properties of Kevlar. That's why care will be taken to avoid impurities in its production. Now let's talk about advantages. What are the advantages of Kevlar fabric? It is highly strong material, and we have talked earlier because it is known for its strength, and but relatively lightweight. But it is strong, but it is also lightweight. Tensile strength of Kevlar 49 and Kevlar 29. These are the grades of Kevlar fabric. It is grade 49 and its Kevlar 29 is over 8 times greater than that of steel wire, and they are more stronger than the steel wire. Bear temperatures up to 450 degrees centigrade. Kevlar fabric can bear temperatures of 450 degrees centigrade, and there is no thermal shrinkage until temperature rises from 450 degrees centigrade. No embrittlement found on very low temperature. If the temperature is very low, like in minus temperature, like minus 196 degrees centigrade, Kevlar fabric will not be broken. Kevlar can remain virtually unchanged after exposure to hot water for more than 200 days. Kevlar can be ignited, but burning stops when source removed. We can burn the Kevlar fabric, but as we stop the source, the burning will be stopped. Resist attacks from almost all types of chemicals, but long exposure to strong acids or bases will degrade it. Degrade is called it's its breakage, its finishing. The material will be finished at that time period. It is highly resist to the attack of chemicals, but as long as we place the Kevlar fabric under the exposure of acids or bases for a very long time, then the material will be degraded. Low electrical conductivity, it has very low electrical conductivity, high cut resistance. It has very high resistance, therefore its electrical conductivity will be very slow, because resistance and electrical conductivity are then inversely proportional to one another. When resistance will be high, electrical conductivity will be low. Now let's talk about disadvantages of the Kevlar fabric. And advantages will be the disadvantages of the Kevlar fabric. It has low thermal conductivity, low electrical conductivity, and high cut resistance. These are also the disadvantages of Kevlar fabric. We can't use this fabric into the materials in which we want to conduct electricity, or where we don't need resistance. Okay. Although Kevlar has very high tensile strength, it has very low compressive strength. That's why Kevlar cannot replace steel as primary building material in structures like buildings and bridges where compressive forces are required. It has high tensile strength, but it has low compressive forces. Therefore, it can be replaced. It can replace the steel as a primary building material in buildings and bridges where compressive forces are required. Fibers quickly absorb moisture, meaning it is more sensitive to its environment than other materials. It can absorb moisture, therefore it is sensitive to the environment. It can be difficult to cut and drill. We can't cut the material easily. We can't drill the material easily. Specially made scissors are usually required to cut the fabric. Therefore, we use special kind of scissors to cut the material or to mold it into the shapes. Kevlar reacts very badly to UV light. That's why UV stabilizer is required for outdoor applications. When we want outdoor applications, obviously there would be UV light exposure. Therefore, a UV stabilizer will always be required. It suffers some corrosion if exposed to chlorine. When it is exposed to chlorine, it can't resist corrosion. It form uh, it suffers some type of corrosion when it is exposed to chlorine. What are the applications of Kevlar fabric? There are some applications of Kevlar fabric. First one is the industrial application. Kevlar is used to make industrial equipment such as hoses, belts. Reinforcement materials is used to make parts of aircraft, ship hulls, reinforced tires. Kevlar is used as a reinforcement material for racing car tires and bicycle tires. It helps to reduce puncture rate because of its strength. Generally, these are much more expensive than ordinary road tires. Tires made up of Kevlar fabric are much more expensive than ordinary road tires. The best example of Kevlar reinforced car tire is American President's car, the Beast. It's the name of the car. Its tires are so strong even a bullet cannot penetrate into it. Sports equipment. Kevlar fabric is also used in sports equipment. It is used in making of various sports equipment due to lightweight and strength. These includes tennis, table tennis, badminton, squash rackets, cricket bats, and hockey sticks, F1 race car parts and body, sports shoes, snowboards, skateboards, surfboards, gloves, rackets, motorsport, helmets, etc. are also made from Kevlar fabric. Asbestos brake pads were initially used in vehicles, but dust produced from these brake pads is toxic. That's why chopped Kevlar fiber has been used as a replacement for asbestos in brake pads. Smartphones, the Motorola Razr family, the Motorola Droid Max, and the OnePlus 2 have a Kevlar backplate chosen over carbon fiber due to its less interference in signal transmission and resilience. Frying pans. Kevlar is sometimes used as a substitute for Teflon. It is also a substitute of Teflon in some non-stick frying pans. Personal safety equipment. These may include Kevlar is used in production of various personal protection gear such as riding shoe, helmets, industrial gloves, firefighting apparel, body pads, etc. In manufacturing of military equipment, because of its lightweight and high tensile strength, Kevlar is used in the production of various army gear such as military helmets, vehicle armors, body armors, tactical waste, fighter planes, wings, and other parts, etc. Applications in medical industry. Kevlar fabric has found various applications in the medical industry, offering unique benefits and advantages for different medical products. Surgical gloves are one of the key medical products that utilize Kevlar fabric. The use of Kevlar fabric in surgical gloves provides enhanced durability and protection for healthcare professionals compared to traditional materials used in the surgical gloves. Kevlar fabric offers superior strength and resistance to punctures, cuts, and tears. In orthopedic implants, Kevlar fabric is also utilized to improve the longevity and performance of these medical devices. The use of Kevlar fabric in orthopedic implants provides added strength and stability, enhancing the overall durability and effectiveness of the implant. This results in better outcomes for patients undergoing orthopedic procedures. It is mostly used in orthopedic implants. It is also used in surgical gloves during surgery because it has high durability and protection for healthcare professionals, and and it provides resistance to puncture, cuts, and tears. Okay. Next one, Kevlar fabric is also used in wound dressings or other medical products that benefit from the use of Kevlar fabric. Kevlar fabric in wound dressings provides increased protection and support for wound healing. The unique properties of Kevlar fabric, such as its lightweight and flexible nature, make it an ideal material for wound dressings that need to conform to different shapes and sizes. Kevlar fabric offers superior breathability and moisture wicking properties, which are essential for promoting proper healing of wounds. How many types of Kevlar fabric? And these are the grades of Kevlar fabric. Let's talk about them. Although Kevlar is main product, there are various other grades of Kevlar produced. Kevlar 29 in industrial applications such as cables, asbestos replacement, brake linings, and body armors. Kevlar 49 high modulus used in cable and rope products. Kevlar 100 colored version of Kevlar. Kevlar 119 higher elongation, flexible and more fatigue resistant. Kevlar 129 higher tenacity for ballistic applications. Kevlar AP, it's 15% lighter tensile strength than Kevlar 29. Kevlar XP lighter weight resin and KM2 plus fiber combination. It is a combo of KM2 plus fiber and lighter weight resin. Kevlar KM2 enhanced ballistic resistance for armor application. It has high ballistic resistance, therefore it is used in armor applications. Sci-fi part. While watching any Batman series movie, have you ever thought without any superpowers like Superman or Wolverine how Batman fight with enemies without getting touched by a bullet? Just because this suit contains more than 50% Kevlar fiber which provides him strength and thus he can avoid bullets like peanuts. Due to Kevlar's lightweight, Batman can easily jump or glide from one building to another. So these are the products in which Kevlar fabric is used. It is the retinal projection system, Kevlar Nomex body armor, Kevlar Nomex groin armor, Kevlar Nomex gloves, Kevlar Nomex knee pads, Kevlar Nomex custom boots, ultrasonic bat attractor, memory cloth polymer cape, four forearm blades, Kevlar Nomex elbow pads, carbon fiber reinforcements, custom graphite coal. How bulletproof armor works. When a bullet strikes on bulletproof body armor, it is caught in a web of very strong fibers. These fibers absorb and distribute the impact energy of the bullet, causing the bullet to deform like a mushroom. So, these are the references where I have collected the material. It's Kevlar chemistry, safeguard armor, Wikipedia, DuPont, explain that stuff, and yeah. So this is the presentation from my side. Thank you.